Hello everyone, this is Teacher Maui of Kalayaan National High School. It's nice to see you. At the end of the lesson, you will be able to apply what you have learned about the application of triangle congruence to construct perpendicular lines. Keep on watching.
Today, our topic is to apply triangle congruence to construct perpendicular lines. Let us first study some of the vocabulary which are very useful in our topic today. Definition of perpendicular. Two lines are perpendicular if and only if they intersect to form right angles. These illustrations are examples of perpendicular. The first one, a line perpendicular to another line, and it forms four right angles. Second figure, a line perpendicular to a ray, and it forms two right angles. The third figure, a line segment perpendicular to another line segment, and it forms four right angles. The fourth figure, a line segment perpendicular to a ray, and it forms two right angles. Take note that perpendicularity is not limited to lines. Line segment and rays can also be perpendicular. Definition of perpendicular bisector. The perpendicular bisector of a line segment is a line, ray, or line segment that is perpendicular to the segment at its midpoint. The first figure, ray is the perpendicular bisector of the line segment. Second figure, line is the perpendicular bisector of the given line segment. The third figure, line segment is the perpendicular bisector of the given segment. Each perpendicular bisector divides the given line segment into two smaller congruent line segments. Bisecting a line segment with a compass and ruler. Step 1. Draw a line segment and name it as AB. Place the compass on one endpoint of the line segment on point A. Then draw an arc above and below the line. Notice that all the points on the arc above and below the line are the same distance from point A. Step 2. Without changing the compass width, place the compass on point B. Draw an arc above and below the line so that the arcs cross the first two. Step 3. Use a ruler to join the points where the arcs intersect. The figure shows that line segment CD is the perpendicular bisector of line segment AB. So, line segment AB is perpendicular to line segment CD. perpendicular bisector theorem. It states that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. We have here triangle AXB. Line XY is the perpendicular bisector of line segment AB. With that, line XY is perpendicular to line segment AB. Point Y is the midpoint of line segment AB. So, line segment YA is congruent to line segment YB, which means YA and YB have equal measures. Since any point on line XY is of the same distance to the endpoints of line segment AB, then line segment AX is congruent to line segment BX. We are now ready to study the first example by applying what we have learned today. Example 1. So this is a figure. We have the big triangle MAP. Given line segment MP is perpendicular to line AS at its midpoint S. Prove that line segment AP is congruent to line segment AM. So here's the proof. Statement number 1. The midpoint of line segment MP is S. The reason is given. Statement number 2. Line segment PS is congruent to line segment MS. The reason, definition of a midpoint. Third, line segment AS is congruent to line segment AS. Reason, reflexive property. For the statement, angle ASP and angle ASM are right angles. Reason, definition of perpendicular lines. Fifth statement, angle ASP is congruent to angle ASM. Reason, all right angles are congruent. Sixth statement, triangle ASP is congruent to triangle ASM. Reason, SAS or side angle side congruence postulate. Seventh statement, line segment AP is congruent to line segment AM. Reason, CPCTC or corresponding parts of congruent triangles are congruent. I hope you do understand our first example. Let's have example number 2. Using the figure on the right, let us solve the equation for x. We will apply our knowledge about the perpendicular bisector theorem. So here is the solution. Since the side measures 2x minus 1 is congruent to the other side which measures x plus 3, we will have this equation to solve for x. Step 1. 2x minus 1 is equal to x plus 3. So let us apply the addition property of equality, or APE, which means we are going to add 1 to both sides of the equation. And the result is 2x equals x plus 4. From this, we're going to apply the subtraction property of equality, or the SPE, which means we're going to subtract x to both sides of the equation. So we have 2x minus x is equal to x plus 4 minus x. And the result is x equal to 4. And this is now our answer. Now, let us check if x equal to 4 is really correct. So from x plus 3, we substitute 4 to x, so we have 4 plus 3, that is equal to 7. And for the other side, we have 2x minus 1. We will substitute 4 to x, so we have 2 times 4 minus 1 is equal to 8 minus 1, which is equal to 7. So 7 equal to 7, meaning they are congruent. So our solution is correct, that x is equal to 4 is the answer. Always remember, perpendicular bisector theorem states that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. When two lines meet and they are perpendicular, they form 4 right angles.
That's all for today. I hope you understand my explanation. See you again on my next video. Thank you for watching.